Are we live? I think we are live. Welcome to Haxe 2019. Alright, here we are. So I watched some of my talks and I realized that I never really actually mentioned who I am. And well, most people here probably know me. I figured it might not be bad for people who maybe watch this for the first time to know who I am. So I'm going to briefly mention who I am. And I am, in fact, Krajewski. I've been using Haxe since 2010, which is almost 10 years now. It's by far not the longest use anyone has. I think Uri has been around since when, 28 or something, 27, yeah, 7 even, okay. So, yeah, and how this actually happened is, back then I was studying computational visualistics in University Koblenz, and I was working on a student thesis involving fluid simulation in the Flash player. And back then, it might sound really stupid now to do something in the Flash player, but back then it was still kind of interesting. It was kind of new, and Adobe Air was just released, and my professor had this idea to try and run a fluid simulation in the Flash player. For whatever reason, I don't know why he had that idea, but I said, okay, let's do that. And so I tried doing that, and well, the thing I was going for, the implementation had like around 100 array access operations per cell per step, and if you're imagining a grid like 256 by 256 and take that by 100, you get a pretty high number of array access that you want to do per frame. So that's a bit of work you have to do, and it turns out that in ActionScript 3 you don't really have a fast array access whatsoever, and I implemented that and it just didn't work. It didn't simulate anything other than nothing, and unfortunately Flash Vector also was too slow, which was really disappointing for me. I don't know why that was the case, because it was hailed as this fixed size, really fast collection that you could use for this kind of stuff, but it really wasn't in my case. So I came across this blog post from Nicola actually, where he was talking about some alchemy opcodes, because at the time Adobe had released some technology named Alchemy, and it turns out that the Flash player actually had some opcodes to support that, and ActionScript 3 wasn't using that, however Haxe was, and so I learned that Haxe was actually up to the task when I implemented this, and my fluid simulation was indeed working, and that's how I got to Haxe. So we can thank Adobe for having slow arrays, I suppose. That's how I got here. And I quite quickly became a contributor to Haxe. In 2011 I made some small fixes. I kind of started learning OCaml. I don't know why I decided to do that, but I felt like, okay, let's learn OCaml. And I managed to fix some of the stuff that I wanted to fix, so I was quite happy about that. And then 1 year later, I kind of became the main maintainer of the Haxe compiler. And well, Nicola was still quite active at the time. He wasn't that busy with his game company yet, so we kind of worked on stuff together, but over the course of the next years, well, I just happened to be the guy who maintained that thing. And what also happened in 2012 was that the Haxe Foundation was formed, and I'm a founding member of that, I suppose. And yes.
One of two.
Yeah, pretty much. But many people have been around, but I guess I was at the right place at the right time, and so it just happens that I was the one who worked for the Haxe Foundation at any capacity. And yeah, that was 2012. I attended my first Haxe conference, WWX 2014, in Paris, so it took me a few years to go there. I don't really remember why, but we just...
I think you watched like the first two on
yeah,
the stream,
I don't
and
know.
you were like, I'd like to go.
Yeah, so I just finally decided to go in 2014, and I went back in 2015, and while doing that I also brought Josephine into the community, who turned out to help us in many ways, so...
It's stuck.
Yeah.
It's like...
He stuck around, and well, she's someone who likes to talk a lot. I'm Actually, not so much. And it took me till 2016 before I actually gave my first talk at the Haxe conference in Paris, where Nicola wasn't present, so I had to fill in and gave my first talk. Then shortly after, a year later, I gave my second talk in Amsterdam. And then in 2018, last year, we started organizing these Haxe ups, and that's why we're here today in my living room, and I'm very happy to see it so packed. It's great to see. And that brings us to 2019, so I'm going to give a brief overview of what happened this year. In February and March, we released 4.0.0.rc1 and rc2. Then in April, big changes for the Haxe Foundation because we recruited 2 people. The first one was Aurel Bealey, who worked for us as an intern for 6 months. And he'll be here this afternoon and talk about the work he has done. The other one, of course, is Alexander, who joined us full-time and has been here since that time. And well, you know how it is. When someone joins the team, you make that person do the stuff you don't want to do. And in this case, that meant going to the US to give a talk at the Haxe Summit in Seattle, where he laid out the new Haxe 4.0 features.
He also went to Hong Kong though.
Oh.
Right?
Yeah.
Yeah.
Yeah, and apparently he also went to
He
Hong
does all
Kong.
the traveling.
Yeah. Then in June we had the RC3 release. In September we had RC4, followed shortly after by RC5 for reasons. And now we are in October and we are here at the Haxe Up. So that's the whole timeline how we got here. And before I continue, I want to give a few shoutouts to people who are not here. And as usual, I have to mention Andy Lee, who is for his unwavering CI work, and he actually ported our entire CI over to Azure, or however you pronounce that. And so we're no longer using Travis and AppWeyer. We are now full on Azure users. And it's great because we don't have to wait like 2 hours for a build anymore. It's much faster now, which gives us a lot of confidence. So thank you for that, Andy. Then, of course, there's Hugh Sanderson, who's still the HXCPP maintainer, despite our best efforts to make the Haxe compilation as difficult as possible from his point of view anyway. Because every time he wants to work on something, it seems like we changed the build system, or I don't know what, and then he gets frustrated. And I'm sorry about that. We're trying to do better, and we try to use a build system that actually just works for everyone, but in OCaml that's not so easy, so I apologize, but we'll get there. Then 2 people, 2 GitHub users, Teru Goru and Krajewski, who kind of showed up out of nowhere and started maintaining HSNode.js, and there were a lot of commits they made. They kind of swept over the whole thing and made great improvements, so I want to thank them for that. Then, of course, Rudy G for his improvements and fixes for the C# target. He is using the C# target. He might be the only one using it, I'm not sure, but he's using it, and if he has issues, he actually likes to fix them, which is great, so thank you for that, Rudy. Then there's George Corney, who keeps maintaining our HTML extents and the generator for it. He's usually very responsive when we have some issue and there's some minor thing that we have to change, and George's like, yeah, sure, I'm going to fix it, and that's always great to have people like that. Then, of course, Jens Fischer, who's still not here this year. I don't know why. I'll try to get him next year. I say that every year. You might know him as Gamma 11, and I want to thank him for his work on VS Haxe and probably everything else, as usual. And then finally, I want to thank all our Haxe Foundation partners. The big ones, the smaller ones, the former ones, the current ones, because without you guys, this wouldn't be possible. And we need this kind of support to have these events, to continue maintaining Haxe, and it's very important. So thank you for this, and we'll hope that this path can continue. So, now we're here. And you know it's time now for the big announcement, because it finally happened. We have made a release, and I am very happy to announce that Nico 2.3.0 is now live. Great. Okay. We also made another release though, and now I'm really proud to announce that indeed Haxe 4.0.0 is now available. And you can download it.
No, not yet.
Not yet, I'm hearing. You can download it soon, by the end of this talk maybe, we'll see, at this URL. And we are very happy to finally have reached this point. And of course we'll continue to maintain it and update it and make patch releases, probably tomorrow to fix some bug or something, we'll see. But we've finally reached this milestone and we're very happy about that. So, since this is the official announcement of Haxe 4, I figured I should probably talk about Haxe 4 as a whole. And I will give an overview of all new Haxe 4 features, which will be pretty similar to the talk Alexander gave at the Haxe Summit 2019 this year. But this will probably be a bit more abbreviated and quickly. So for more details, you can check out his talk, which is going to have more code examples and that kind of stuff. So let's just start with one of the features. We have a new macro interpreter compared to Haxe 3.4. It's bigger, it's faster, and of course it's stronger too. And I talked about it at Haxe Summit EU. Since then, we've made improvements to the debugger. It's actually useful now and works sometimes. And we stabilized the API. We fixed many bugs, of course. And one of the big things we did, we worked the entire string implementation, and this is the beginning of a whole segue chain that's going to happen, because now I'm going to ask, why did we rework the entire string implementation?
Tell us.
I will. And the reason for that, of course, is because we now have Unicode support. And I talked about this right here last year. So for the details, you can check out this talk. Basically, it means that this string now has length 10 on all targets except Nico. And the idea is that we support at least UCS2 on all targets. So we let targets use their native representation, because everything else would just be super impractical. So the way we define it is JavaScript, Flash, Hashlink, and C++ use UCS2. Eval, PHP, and Lua use UTF-8. Then we have Java and C# who use UTF-16 natively. And then we also have the Python target, which uses UTF-32 probably. And I'm still not sure, it depends on compilation parameters or something, but it definitely supports the thing. And there, as I mentioned, there's no support for Nico. So, sorry Nico, it is what it is. And as a consequence of having this, you have to be careful with surrogate pairs. I mentioned that in detail in my talk last year. On targets that use UTF-16, so that's Java and C#, and on targets that use UCS2, you kind of have to be aware of that, so keep that in mind. And something else that often comes in pairs are key-value iterators, because you have key and value pairs, right? So we now support this kind of syntax. If you have a map, you can loop over it using this key arrow value thing. And then you get the key and the value. That's really all there is to say about that specific example. We support it for map. It's not yet supported for array. There were some issues with it, and it's also well, it's not that useful usually, but at some point we'll also support it on array. And you can support custom iterators by implementing your own method, key value iterator, where's my mouth? Key value iterator, which returns an iterator which has a key and a value. And yeah, you can use it on custom classes the same way you use iterator. And it's also supported on string. Oh, hang on. How do I get this doc out of the way?
You click right on it. I can hide it.
Install window.
There we go. Okay, with that gone, it's also supported on string with if you using string tools. So it's not supported on the string class itself, you have to add this. But in my experience, that's probably used in most projects anyway, because it's so useful. And now, speaking of using, we also have a new feature named meta using. And what this allows us to do is associate static extensions with types at the type definition level. So in this case, we have this enum, my option, and it's associated with my option tools. And you can see here there's a function which allows us, well, the first argument is my option, which allows us to use it as a static extension. And on use sites, we can just use, without having to do anything else, you can always call this get function down here on every instance of this my option enum. So there's nothing else you have to do, and it's quite useful, especially for enums, because you usually can't implement functionality on enums directly. But this way you basically can. And it's a nice way to separate this data definition from the function definition. And you can see in this case we have this wonderful inline function get. So it just optimizes everything away actually, because the compiler can see that we have this sum 12, and once we inline the get function, it will see that, okay, we're always using this case. And so the output here will just be trace 12. If that function wasn't inline, you could instead use call side inlining, which just means that if you have a function which isn't inline, you can at the call side now say, okay, please inline that function. And it's also one of these features. It's quite useful, but there's not much to say about it because I already said everything just now. You will see in the output that we indeed, from the previous example, just get this 12 down here. So there's no calls, there's no enum matching, it's just a nice 12. And that's often useful when you have generated code which might generate switches or generate other code. So it's nice for the compiler to optimize all that away. And you can see I'm demonstrating this showing the JavaScript output because that's usually a good way to say what we see what we generate. And speaking of JavaScript output, we now have an option to generate ES6 thanks to the work of Nadako. So all you have to do is just add this define, and the previous example will then generate this code. It looks quite similar if you compare it, but we now actually have a real class with a real static function, and I think everything just works right now, right? We don't have any known problems. So if you like clean JavaScript output, whatever that may be, you can use that. And one thing to note, we still output just a single JS file at the moment. There's no automated splitting. You have to use external tools for that. I don't know if we will add a functionality for that, so you get like one JS file per HX module. It's been an ongoing discussion. We might add it to the Haxe compiler at some point, but at the moment I can't tell you if we will or won't. So, speaking of automated stuff, we can now automate, when you have enum abstracts over integer, we automate the value assignment. So in Haxe 3 you will have to assign a value to each of these constructors. In Haxe 4 it infers it very much like in C. So the first value will be 0, then 1. You can define explicitly in the middle, and then it will just keep counting. And that's very useful. And the same, well, not the same, but something similar can be done with string, where it just uses the name of the constructor as the string value. So you can just imagine that there's equals first, equals second on these lines. And that's also very useful, I think. Now, some general syntax improvements that we made. Instead of enum abstract as metadata, you can now write enum abstract directly, which looks much nicer. Instead of extern function, you can now write extern function, but without the metadata stuff. Instead of this weird thing, you can now write this less weird thing, which we call intersection syntax. So it's the same functionality you get. It's used with structures mostly. You merge two structures basically, so the resulting type gets the fields of type A and the fields of type B, and that's called intersection. And this is also used for, most people probably haven't even seen this. This is a type parameter constraint to two values, to two types. So T is constrained to A and B in this case. And in this case we now also use the intersection syntax. So we say that T is constrained to A and B, and it has the same meaning. We still support the old syntax, but consider it deprecated, except for the multiple constraints syntax. And the reason for that is that we actually have a syntactic conflict in this case, which brings me to my next topic, which is the arrow function type syntax. In Haxe 3 you would write string in void like this. Functional programmers are probably very used to this, to writing it like this. And in Haxe 4 you can now write this, which might be more natural to people, because it looks more like the function definition would as well. And you can also add names to it, which is mostly useful for documentation. It has no effect on the typing itself, how types are unified or anything, but it's useful because it looks better, and you can associate a name with an argument. And in this case also the Haxe 3 syntax is still supported, and we also didn't deprecate it because we think that it would be quite annoying. I also always catch myself still using the Haxe 3 syntax when I write code, and I usually arrive at that first arrow and remember, oh wait, we can do this differently now. Now I've already written that arrow, let's just keep going, and then I keep using the Haxe 3 syntax. But I try to make an effort to use the new one because it really does fit better. And well, of course we can't only define types, we can also define expressions, and that's the most requested feature of all time. Was something, I believe, the short lambda syntax we now supported. And well, it's quite straightforward, right? You have a function with an argument a, and it returns an argument, the value a times 2 in this case. You can put parentheses around it if you want. You can add a name to the argument if you want. Again, mostly a type to the argument if you want. This is actually sometimes useful for typing. And you can also use multiple arguments like this. And you can also type these, of course. We always, with this syntax, have an implicit return, so you will see that I don't have to write return a times 2 here. It automatically returns that value. However, we do not use implicit blocks. So this isn't block scoped. If you want to have multiple expressions here, you'll have to open a block manually. And That's just something to keep in mind because sometimes it leads to some weird errors. And another limitation is that you cannot type in the return type, and there are syntactic reasons for that. I won't go into detail, but basically if you had like the colon type here, then it's not really clear what this arrow belongs to, because it could, and probably is, the arrow that belongs to the expression, but it could also be the arrow that belongs to a function definition over here. So that gets kind of messy, so we decided to not to support it at all, and you usually don't need it. So, because you write the value here anyway, so in my experience you don't need it. And you'll find that the syntax is quite similar to Java 8 short lambda notation, which basically looks the same. It works a bit differently, but it should be quite similar. And speaking of Java, we now have a JVM target, and how did that happen? Well, I don't know. It just kind of appeared out of nowhere, and you can now just add JVM when compiling to the Java target, and then you get JVM output, which means that it generates a jar file with class bytecode, so you don't need the Java C compiler at all, which leads to much faster compilation time. And we don't have to detour over the syntax. We don't have to generate Java code and then get the Java compiler to generate the bytecode for us. We just do it directly, which means we have to do way less workarounds. The current state we label it as experimental. There are some reasons for that. The performance is, at the moment, slightly worse than the real Java target.
That's not true.
Well, that's in general, I would say, because there are some cases where it's just worse. And we know why, we know how to fix it, but it requires some work and some thought. So that's just the current state of affairs, but we're going to improve it for sure. And also what's important is that in the grand scheme of things, compared to other targets, it's still really good actually. Because the Java JIT and the Java runtime are just, at this point, quite fast. And I kind of grew up thinking of Java as this really slow and sluggish and weird VM, but over the years, it's surprising how fast this stuff has gotten. So don't underestimate the Java runtime. We have some problems with method handle usage, because it turns out that on Android this isn't really supported. And I was really happy to work on Java, because I figured, well, it's Java, everything is super well defined and works everywhere, there's specifications for everything, and then it turns out, yeah, well, in some cases that's not really true, like this, it doesn't work, and of course I didn't know until I already finished the target, because I never tried it on Android. So we probably have to put some work into that. And thanks for the message. Okay, and some comparisons between the genjvm and genjava. The compilation speed for genjvm is fast, for genjava it's certainly not fast. That's all I want to say about it. Performance, I label it as fast, but genjava in general might not still be a bit faster. Type parameters, as far as I know, we don't have any case where it doesn't work. And in the Java case, there are some issues with type parameter usage. And as I mentioned, for function references, we use method handle, which causes us some issues. And again, Java is what I can only describe as Wagner functions. And it sounds weird, but it turns out that the implementation car we made is actually pretty damn fast, because there are so many optimizations specifically for Haxe calls being made. The code looks really bad and not clean at all, but it turns out that it's actually a good way to make it really fast. So that's something we might have to look into, because we might have to replace method handle anyway. So we'll see what we're going to do. If anyone knows a Java expert who has knowledge of this kind of stuff, so please contact me. And some general performance advice when working with Java and genjvm. Allocations in general are fine. You don't have to worry about making allocations that much like you have on some other targets, because the GC just in my experience, doesn't care that much. You should, of course, still avoid allocations if you can, but it's not like you have to design your entire applications around the fact that you have to avoid allocations. And for JVM, you definitely have to avoid the class access through structures. So if the compiler doesn't know that you're accessing a field on a class, no, if the compiler sees a field accessed through a structure, but it turns out it's actually a class field being called, that's pretty slow in genjvm, and that's one of the situations where Java is much faster. And unfortunately, that includes iterator. That means that in some cases, iterating over a collection may be slower than it could be. And we'll improve that, of course, but for now, try to avoid this situation if you want to get the best performance. And my advice is also to don't inline too much in Haxe, because the Java JIT kind of knows what it's doing. I think that's true for JavaScript too, in many cases, so don't over inline, use inline judiciously, and definitely avoid nullity like the plague, especially when doing any kind of math, because if you add two nulls together, the runtime has to check, okay, is the first one null? Is the second one null? And that already leads to four permutations, so you go to this kind of branching, and then you still have to do the operation, and in some cases you actually have to wrap this stuff back to a null instead of a native value, and that's just really, really slow. So if you want to do any kind of heavy math, don't use nullity whatsoever. And something that might help with avoiding nullity is the new null-safety feature which Alexander implemented. He went into detail on it right here last year, so you can watch his talk for that. You can now add null-safety. In this case, I use strict, and we have an argument which is optional, which means it can be null. And then if we access a method on that argument, if this is enabled, we'll get an error that you cannot access char add of a nullable value. So if you add something like this, the compiler is happy about it, because it sees that, okay, we did check that it isn't null, so at this point we can in fact access the value, no problem. And you can configure that per package, per type, and per field. On package level, you can add a configuration macro, and by doing this, in this case, my pack will be in a specific mode. I'll talk about the modes in a second. And at type and at field level, you can do this via metadata with the same kind of mode. And mode is either strict, loose, or off. That's the options at the moment. The global default, if you don't use null-safety, enable null-safety at all, is off, of course. If you enable null-safety, the default is loose. And the key difference between loose and strict is that loose ignores potential mutability. And we can see that in this example. We have this static, where's my mouse? We have the static x, which is a nullable. In this case, well, it could be null actually. So we check here that x is not null. So we know at this point here that x is not null. But then we call a side effect, and the function doesn't look at what side effect does. So it assumes the worst, and it assumes that a side effect might in fact set x to null. So in this case we do get the current failure at this point. And yeah, that's what I just said. The x could be mutated. At least that's how I think the strict mode should work. It's not quite like that, but that's what we are going for. And yeah, because the small detail here is that it actually assumes that a different thread may also set x to null. So basically that it can happen from anywhere, and that means, well, you basically can't use mutable fields at all, in my opinion, because I don't know how you would ever check against that. You would have to store them in a local variable, right? yeah, you would have to assign the field value to a local variable and then check that for null. That would work.
Or you can use a static extensions which do that for you.
Or you can use a static extension switch. Yeah, that's true, I suppose. So yeah, we'll probably fine-tune that a bit, but if you want to use null-safety, check it out. So what can we do to help the compiler in that regard? Because we can tell it that something isn't mutable, and for that we introduced the new final keyword. So instead of var, you can use final now. So you can declare the static final countdown. And that just means that the field cannot be assigned to after the initial assignment. So as a consequence, you have to initialize, the compiler checks that the field for static fields, it must be initialized directly, and for non-static fields you can initialize them directly or in the constructor. And if you don't do that, the compiler will complain about it, because then you could have a nullable value. And you can also use that as at expression level. And of course, you can also use final as a class modifier. So this is, inheritance is disallowed. That's standard OOP stuff. And of course, you can also use it as a field modifier to disallow overriding. That's also standard OOP stuff. And in theory, this allows some optimizations because the compiler can make assumptions about the field always having the same value. But at the moment, we don't do that much yet. There is some small optimization in eval which makes calls faster because it can assume that the field isn't overridden. So it can just call the field that it knows, and we have more people. Hey, robot arrived, welcome. And yeah, as I said, not much yet, but maybe there will be stuff in the future. And speaking of the future, this is the end of my overview of the Haxe features. So I'm just going to give a brief overview of what we're planning to do and might be doing. We're working on asynchronous I/O support, and Oral will talk about that a bit later today when he arrives. We also want to work on coroutines. That's probably the big feature that we're going for, and we're not sure if it's going to land in 4.1 or maybe a bit later. There's still a bit of design to do, and we'll probably sit down together later tonight and try to figure out what to do with it. We'll see. Then it's kind of related. We also want to look into making tail call optimizations, which is important when you work with recursive data. So you kind of want to avoid this situation because you don't want to have that many calls. You want to have one loop that handles all that, because making calls is actually kind of expensive compared to other things. And then finally, we also may want to look into supporting module level functions. That's something, I don't know, it seems like there's sometimes people really want that and are really like, okay, we definitely need that. And then you talk to them a month later and they're like, yeah, it's not that important actually. And it kind of goes up and down. So I'm not really sure right now if we're going to do that, but we might. It might be useful in some cases to not having to define a class and just define a function on a module level. And that's it for me. So thank you very much. You may. Thank you. Please clap. Okay. Are there any questions? No, everyone is happy?
Everyone is too hungover for questions. We did this well.
Could you show us the fluid simulation thing?
I don't have the URL right now. I can show you later though. It was quite impressive actually, the fluid simulation. I'll show you later. So is anything on Twitch? Any Twitch
I
chat?
don't see anything on
Okay,
Twitch.
that's
Except
fine.
that I forgot to change the title of the screen. It still says Haxe Summit CL, so yeah.
Oh, we can change it.
But other than that.
Alright, then that's it for me. Thank you everyone.